Almost all spray systems need a pump to deliver the fluid being sprayed at pressure to the nozzles. There are many types of pump on the market. This is a short guide to pump selection for spray applications. So what are the common types of pump? First, let's look at diaphragm pumps. Now, diaphragm pumps create pressure by a pulsing diaphragm. For additional pressure, these can be multi-staged. There are many sizes and types of diaphragm pump. With this range of pumps, you can find maximum pressures up to about 15 bar and maximum flow rates of about 1900 litres per minute. Diaphragm pumps have several key advantages. Firstly, they can run dry without damage, self-priming with excellent suction lift capacity, and they can have excellent chemical compatibility, as diaphragms can be made from a wide variety of chemically inert materials. And the main drawback is a pulsating flow, which needs to be compensated for with flow dampening if a smooth delivery of fluid is required. So when to use these in spray applications? Well, firstly, when spraying aggressive chemicals such as acids. Secondly, if the system may run dry from time to time, they're a good choice. And if the system needs to be self-priming, they're also an excellent choice. So let's look at centrifugal pumps next. These pumps use rotational energy from an impeller to generate pressure. Again, there are many models available, but the general maximum pressure for this type of pump is about 20 bar, with many models only being able to produce 2 to 3 bar. The main strength of centrifugal pumps is the flow rates they can produce. Now, there are many smaller centrifugal pumps which can only deliver a few litres a minute, but there are also huge pumps that can deliver truly huge flow rates of 200,000 plus litres per minute. So for large flow rates, they're definitely a pump for choice. So they have several key advantages. They give a smooth and even flow rate, they potentially have a very large capacity as discussed, and they're very energy efficient at the design point, i.e. at the right point on their pump curve. Now, the main disadvantage is that they have variable pressures. So as flow rate decreases, the pressure delivered increases. This is known as the pump curve. And without proper pressure regulation, this can have implications for some spray applications. So when to use in spray applications? For large flow rates or for big arrays of nozzles, for example in a pre-treatment spray tunnel, they're a good choice. When energy efficiency is a key consideration, for example in indirect evaporative cooling systems, they'll be a very good choice. And for lower pressure applications, generally speaking. So let's look at positive displacement pumps. And these pumps use a rotary action or pistons to displace fixed volumes of fluid. They can achieve very high pressures, and unlike centrifugal pumps, will maintain a constant pressure regardless of the flow rate. And the main advantages of this type of pump are they can deliver high pressures up to 2000 bar for some models. They give a constant flow rate independent of pressure, and they give precise metering of fluids. And the main disadvantage of positive displacement pumps is that they're generally more expensive to buy, more complex, and so require more maintenance. So when to use this type of pump in spray applications? When high pressures are needed for misting or fogging applications, for example, they're a good choice. When exact dosings are required, for example in coating applications, they're a good choice. And when it's important to maintain consistent drop size with variable flows, because that constant pressure ensures a constant drop size. So in summary, selecting the right pump for your spray application is vital. At SMP, we're experts in spray nozzles, but we also have a wide variety of pumps available. We use our expertise in spray applications to help you select the right pump to match the nozzles we have specified for you, so you can be assured that the system will work as designed.